Hello. Today we're going to move on into our section of probability. So there are a couple of types of probability we're going to talk about here. One of them is experimental probability. That is the number of times an event actually occurs out of the number of trials. So this is when you're actually watching things happen. It's not a thought process, it's observation. So to find that probability, and this is a way that you express probability, that notation here, that is the probability of the event is the number of favorable results out of the number of trials. So the number of times what you're looking for actually happened out of the number of times you observed that trial happen. So example one here, let's say Dante, good basketball player, has made 23 three-point shots this year on 52 attempts. What is the experimental probability he makes a three-point shot he attempts? So there are a couple of ways that we look at probability. First, of course, is this fraction up here. So the number of favorable results. We want to know the probability he makes a three. The number of times he has done that is 23 times. So we would say the probability he makes it is 23 out of the number of trials. He attempted to make the shot 52 times. Not all of them went in, only 23 of them did. So then we want to look at simplifying this fraction first, see if there is a number that goes into both of these. This is actually a simplified fraction already. 23 is a prime number, and 52 is not divisible by 23. So we could just express the probability as this fraction. We also can express it as a decimal. So we could divide 23 by 52 and see that it is 0.4423 thereabouts. So this is about equal to 0.4423, which means it is about 44.23% of the time that he makes his threes. So technically, any of these three answers is correct. A lot of the time you will be asked to use a certain type of answer, a fraction, a decimal, or a percentage. Usually in basketball terms, you measure this as a percentage. So we'd be looking at 44.23 there. And if you remember, you just have to move that decimal place 2 to the right to convert a decimal to a percentage, or vice versa. You can move it 2 to the left to go from a percentage to a decimal. You can also always multiply by 100 here and see the percentage. The other type of probability we're going to talk about today is theoretical probability. That is the reasonable predicted probability of an event occurring. So that is not what you've observed, but what you really know should be the case. So if I flip a coin 10 times, it's not always going to come up the same number of heads and the same number of tails. But that is what I would predict mathematically. They should be two evenly likely occurrences. So the probability for both of these, whether it is a head or a tail, is theoretically 1/2. Because there is one head and two sides of the coin, one tail and two sides of the coin. 1/2 is equal to 0.5 or 50%. We can apply this to rolling a die. So typically when you hear die, you think of a 6-sided die, unless it's otherwise specified. So this is a die with a 1, 2, 3, 4, 5, and 6 on its sides. So the probability of rolling a 5, there's only one 5 on the die, and there are 6 sides to it. So there's one favorable outcome and 6 equally likely outcomes. And 1/6 is about, there we go, might have lost you for a second, about 16.7% if we were to round. The probability of an even number is a little bit different. So there are 3 even numbers on the die, 2, 4, and 6. There are 3 sides to the die, so it's 3 out of 6, which is 1/2.
or 50%. That's exactly equal to 50%, actually.
And then drawing a card, I've been made aware that not everyone is as familiar with cards as I am, so I'll give a little explanation, and I have kind of stopped asking questions about cards because not everyone knows them. But as an example, typically a deck of cards has 52 cards in it if you don't have the jokers in there. And the probability of drawing a 7 of clubs, that's the symbol for clubs here, there is only one of those on the deck. So that is 1 out of 52. And 1 out of 52 suggests that that's about a 1.9% chance of happening. The probability of drawing a diamond, on the other hand, there are 13 diamonds in the deck. You've got 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King, and Ace. So that's 13 out of 52. It's also, that is equivalent to 1/4, because 13 will go into 52 4 times. And that is 25%, because there are 4 suits in a deck: diamonds, clubs, spades, and hearts. Each of those is equally likely, so that's also where we could get our 1/4. Then I'll just do a couple of examples here real quick. So example 2, if a die is rolled 30 times, what is the expected number of times a 6 is rolled? So this is theoretical probability. We're not saying we actually rolled it 30 times and we know how many times it came up. We're trying to figure out how many times we expect that to happen. So we should know the probability of rolling a 6 is 1/6. There is only 1 6 on the die, and there are 6 sides. And we're going to roll it 30 times. So if it were to happen exactly 1/6 of the time in those 30, it would happen 5 times. So that would be the expected outcome here, is that we would roll 5 6s. The expected outcome would actually be 5 of everything. That's actually not likely to happen, but we would expect about 5 of each. And then our last example for this video here. This is actually going to be a multiple choice problem. So I'm going to zoom out a little bit, see if we can get this whole question in on the screen. A bag of marbles contains 12 red marbles, 16 blue marbles, and 24 green marbles. Okay. Here we go. How many additional red marbles must be added to the 52 marbles already in the bag so that the probability of randomly drawing a marble is 1/2? So this is a case where we're going to look at the probability first. So before we add anything into it, what is the probability of pulling a red marble out of this bag? They were kind of nice to us and told us that there are 52 total marbles in there already. So right now, the probability is 12, because there are 12 red marbles out of 52. And again, with them being a little bit nice about this, we have multiple choice options. So we don't actually have to solve this out. We can just check which of these answers would work. So let's say we put answer choice A, 14 red marbles into this bag. That means we would be adding 14 red marbles, so there would be 14 more favorable outcomes there. But we're also adding 14 total marbles to the bag in that case too, so we're affecting both the number of red marbles and the total number of marbles. So we've got the fraction 12 plus 14 over 52 plus 14, and that would give us 13 over 33. So this is less than 1/2 right now. So we're going to need to bump it up. So here we would have 12 plus 20 out of 52 plus 20. Let's change those 14s here to 20s. See what we get in this case. That simplifies down to 4/9, which means we're in the ballpark. So this one would be 12 plus 26 over 52 plus 26. So change these 20s to 26s. And we get 19 out of 39. Not quite a half, but we're very close. So 12 plus 28 out of 52 plus 28. Going to see if that works. That is what would give us a half. That would give us 40 red marbles out of 80 total marbles on the bag. So that is our 1/2. So our answer choice is D, 28 red marbles that we would have to add to the bag here in order for the probability, theoretically, of pulling a marble out of the bag to be red, to be 1/2.